Robert Owen Inc., Wireless Sensor Networks with the ROI-RFX. Wireless Sensor Networks, products and systems designed for simple use with the ROI-RFX. Wireless measurement functionality. Functionality of the ROI-RFX. 24 volt DC powered, 2.4 gigahertz 1 mile distance, customizable, surface or DIN rail mount, Euro plug connector. Wireless measurement software. Software available for the ROI-RFX. Excel sample acquisition spreadsheet provided. Custom code possible. Wireless measurement uses. Uses of the ROI-RFX. Remote transmitter measurement. Remote sensor measurement. Typical configurations shown in the following slides. Configuration 1 uses the ADCs of a local 2.4 GHz ROI-RFX module to read sensor voltages and transmit them to a wired PC serial port. Simple Windows programs are available for processing the readings. Configuration 2 is to use the ADCs of a remote 2.4 GHz ROI-RFX module, transmit the messages to a local 2.4 GHz ROI-RFX, read the messages using a PC connected serial TTL UART. Simple Windows programs are available for processing the readings. Configuration 3 is to use the ADCs of several remote 2.4 GHz ROI-RFX modules, transmit the messages to a local 2.4 GHz ROI-RFX module, read the messages using a PC connected serial TTL UART. Simple Windows programs are available for processing the readings. Network configuration 1 shows a USB TTL UART seen as a COM port by a PC connected to a local ROI-RFX. The local ROI-RFX is connected via ADC to an analog sensor. Up to 4 sensors can be connected per module. Update rate requirement is not high. Network configuration 2. A PC USB TTL UART is serially connected via TTL to a local ROI-RFX, which is in communications with a remote ROI-RFX via 2.4 GHz. The remote ROI-RFX ADC is connected to an analog sensor. Each ROI-RFX module can be connected up to 4 sensors. Serial port expansion of a number of sensors is possible. Update rate in this application is not high. Duplicate networks of this type have also been set up using 900 MHz modules. In a more detailed view of network configuration 2, the PC connected ROI-RFX also requires a local DC power supply that may be referred to as the receiver. The transmission distance of the 2.4 GHz signal is up to 1 mile, which is line of sight dependent between the 2 antennas of the 2 systems. A remote ROI-RFX, otherwise referred to as the transmitter, also requires a local DC power supply. Its ADC can be connected up to 4 analog signals, such as 4 to 20 milliamp transmitters. Network configuration 3 shows a PC USB TTL UART serially connected via TTL to a local ROI-RFX. The local ROI-RFX is connected to multiple remote ROI-RFX modules via 2.4 GHz connections. Each remote ROI-RFX ADC is shown connected to an analog sensor. Each ROI-RFX module may be connected up to 4 analog sensors. Serial port expansion also allows a number of sensors to be connected via the serial port. Update rate requirement is not high in this application. Several remote modules may be in a typical installation. A detailed view of network configuration 3 shows how the PC connected local ROI-RFX, which requires a local DC power supply, may be centered between multiple remote ROI-RFX modules. In this particular diagram, each is centered in completely opposite directions. Each may be up to a mile from the receiver PC connected unit. The remote transmitter connected units each can be connected to up to 4 analog signals, such as 4 to 20 milliamp transmitters. In an alternate detailed view of network configuration 3, a diagram indicates that each ROI-RFX transmitter module may be connected serially to the receiver PC connected ROI-RFX module. In this particular diagram, it's demonstrated that transmitter module 1 may be up to 1 mile from the PC connected receiver module. Each additional transmit module may be connected up to 1 mile from the previous transmitter or the receiver module, depending upon the part of the serial transmission. In this particular diagram, it's demonstrated that a total distance can be achieved up to 4 miles between the last module transmitter and the receiver. In the following slide, cloud network configuration is shown. How it works: the configuration uses the ADCs of remote 2.4 GHz ROI-RFX modules to read sensor signals, transmit them to a 2.4 GHz ROI-RFX module, which is wired to a Wi-Fi ROI-RFX module, transmit the messages to an existing Wi-Fi router, post the messages on the cloud in an IoT configuration. Diagram of cloud-connected ROI-RFX 2.4 GHz network for IoT shows that the Wi-Fi router is open, but best to assume an existing network with third-party equipment. Local to the router is the ROI-RFX. Two modules will be electrically connected together to act as a bridge between the Wi-Fi system and the 2.4 GHz networks. One UART connected ROI-RFX 2.4 GHz module can be connected to multiple remote 2.4 GHz ROI-RFX modules, each module's ADC reading analog sensors. Up to 4 analog sensors can be connected to each remote ROI-RFX module. The update rate of the requirement is not high. It would be great to use for monitoring of periodic status. Up to 7 modules may be typical. Remote status of several locations spread far apart would be a typical application. For more information about these or other Robert Owen Inc. products and systems, visit our webpage, follow us on Twitter, like us on Facebook. Thank you.